Good day to our lecturer, Dr. Zulkifli. My name is Patrick Solangambun, and I would like to introduce to you our project entitled 2 Degree of Freedom Suspension. Before that, I would like to introduce our group mates. The first one is Muhammad Aidil Aswad bin Tuah, which is our group leader, and our fellow group mates, followed by Nur Shahira binti Muhammad Arif, Muhammad Imran bin Sharon Nizam, Muhammad Azman bin Nazim, and me, Patrick Solangambun. Okay, for the introduction of the project, the 2 degree of freedom system have two equations. As we can see on the figure shown, it have different masses or separate masses. The masses free body diagrams are depicted in the illustration, and the equation of motion is obtained from applying the Newton's second law of motion towards each of the mass. For F1 and F2 are external forces acting on the mass 1 and mass 2. The equation of motion is obtained by applying Newton's law of motion as shown in the illustration given. For the problem statement, our problem is to identify the voltage used by using the piezoelectric transducer, as well as to able to identify the relationship between piezo vibration and vibration theory. We also wanted to figure how to move the shaker from the crank system so that the trolley can move in linear motion. Our objective for the project is to design the system using appropriate software and also 3D printing method. We also wanted to integrate Arduino based system to find the static region, which is to find resonant frequency, natural frequency, and steady state purpose. Last but not least is to compare the experimental data with the theoretical data. Our significant project is to create a mechanical arrangement prototype that able to run at a set value of revolution per minute. The next one is to develop a 2 degree of freedom system at free vibration, and also to investigate free vibration with 2 degrees of freedom. And for the next part, I would like to leave to my group mates, Nur Shahira, to continue the next part. Thank you.
Assalamualaikum. My name is Nur Shahira. Basically, this section will be more focused on the literature review. A vibration or oscillation is any repeated motion of an object over time. During vibration and oscillation, an object energy continuously switches from potential to kinetic. Forced vibration and free vibration are the two main forms of vibration. Damped vibration occur when a vibration system is damped. Damped forced vibration and damped free vibration are two types of damped vibration. Undamped vibration occur when the damping process is neglected by the vibrating system. The undamped vibration also divided into two categories, which are undamped free vibration and undamped force. Vibration is caused by inertia and elastic forces. An object inertia can be described in terms of mass, moment of inertia, and displacement. Speed can be expressed as displacement or stiffness of an elastic element like a spring. Undamped vibration is when a natural vibration occurs as no additional energy or force is added to the vibration system. Free vibration occurs when an object oscillates or vibrates with only one initial disturbance and no external forces add on it after that. The amplitude of the undamped free vibration remains constant since no energy is dissipated as shown in figure below, while damped vibration is when damping occurs in most situations because resistance and obstruction are caused by the external factor like friction. As demonstrated in the figure below, the amplitude of the damped free vibration steadily decreases. For a system to move, it needs to process as many independent coordinates as possible. The 2 degree of freedom vibration system move in two directions. Simple harmonic motion occur when musical instruments produce vibration that form sound waves in the air. Musical sounds are made up of several simple harmonic waves that are overlaid on one another and are multiple of a lowest fundamental frequency. While Hooke's law approximates the response of elastic, like spring-like bodies in mechanics, small displacement of their constituent molecule, atom, or ion from normal location are proportional to the forces that generate the displacement. It states that a spring extension is proportional to the applied load.
Hello, my name is Hazman and my part of this presentation is the methodology. We'll talk about the flow of the project process as shown on the slide. On this slide, we can see there's a two flowchart of the project. I will talk about the left side first. Okay, first we start with the design the replica theoretical problem. After that is the simulate the design. If it's failed, we will go back to the design the replica theoretical problem. If it's successful, we can move to manufacture the design component. After that is the assemble of the component. If the component fail, we will redesign back to the design replica theoretical problem. If it's successful, we can move on to the final step is the collect data. And on the right side of the flow chart of the project is where we start with the problem statement, design, 3D modeling in CATIA, simulation, 3D printing, part installation, run experiment, collecting data, and end of the project. On this part, I will talk about the list of components. The table on the left shows the total material and cost for the prototype. Okay, as you can see the component here, the component we're using 11 type of component. First is Arduino, potentiometer, motor driver module, DC motor, wire jumper, battery and clip here, 3D printer model, tire, a spring and piezoelectric vibration sensor. And the total quantity is 17 quantity we're using, and for the cost here, the total cost is RM289.90. For the flow work on the project, our team make a rough sketch on 2 degree of freedom project, as you can see on the first photo at the left side here. And then afterward, we design by using CATIA, as I mentioned at the methodology flowchart, where we will design in the 3D modeling using CATIA. And then afterward, we do a simulation on the system using CATIA software. These are the product that has been designed in CATIA software. On the figure left shows the exploded view of the component design in CATIA. You can see there are multiple products here for that we have designed. On this slide here is the drafting on each part of the product, where on this first slide here is the arm. On this slide is the drafting for the box, where we put all our component inside here. This is the drafting for the car. This is the drafting for the disc, where it will connect with the arm on the first slide there. And then this is the holder, where we'll connect with the spring, and then we connect with the arm. This is the design drafting for the cover box. Lastly is the assembly part, where we combine all our component into one product. The assembly part is for us to ensure all the component can fit nicely with each other before the fabrication, the 3D printing.
Assalamualaikum and good day. My name is Muhammad Aidil Aswad. I will explain next part of this project. The next flow work of this project is 3D printer part. They have 8 parts that need to be printed, which is the box, 2 pieces of car, arm and holder for shaker the spring, disc that rotate at 45 degrees, and lastly is drill. We are using 2 types of 3D printer machine, which is Ender 3 Max and CR10 version 3. For slicer software, we will use Cura slicer for setting before print using 3D printer machine. We use 10% infill, 70% speed, and have a support tray for box, car, arm, and holder spring. For body, it takes 1 day and 20 hours to print. One car, it takes 1 day to print. For trail, it takes 1 day to print 2 trail, and others just take 15 to 30 minutes each part. After all parts were printed, the components were assembled including the wiring. This slide shows the wiring inside the box. All the electronic parts are placed in the box except the battery at outside box and piezo vibration sensor under the car. The picture shows the coding inside the Arduino. What we can see, they have two equations in the coding, which is Hooke's law and simple harmonic motion. Output of piezo sensor is worked, then change it to the force. Spring K is get from the formula simple harmonic motion, and then the distance X it get from the formula Hooke's law. This slide shows the figure of the result of prototype from fabrication. This slide shows the video demonstration of prototype 2 degree of freedom mechanism. This slide shows the result data from the programming. The data shows the result speed, distance x1 and distance x2. The graph shows the result on the speed unit pulse width modulation PWM versus 2 distance x unit cm after run tests were conducted. The notation of this table attached can be used to construct a graph with speed and distance x of the spring. The observation of the distance for x1 is the car 1 or purple car, while for distance of x2 is for the car 2 or black car. The speed recorded at the beginning of the experiment is 0 speed, while the distance of x1 and x2 is recorded before the value of speed increase. By comparing the distance x1 and x2, when the speed was increased, pulse distance also increased. But by observing the graph above, the distance of x2 has a slightly different characteristic compared to x1. This is due to the fact that the car 1 distance x1 is connected to the crankshaft or holder spring, while car 2 distance x2 is connected to car 1 by spring connection. In addition, the project angular velocity is kept as a manipulated variable, but the angle of the D is kept as a constant variable with a 45-degree rotation.
Assalamualaikum, I am Muhammad Imran and I will present about discussion, recommendation and lastly conclusion. So first of all, for discussion, the parameters applied in the experiment are based on the theoretical value. The spring's velocity and acceleration are configured to be constant variable. The frequency of motion will be responding variable in the experiment. The Arduino program records the speed and frequency of the spring movement. The percentage error can be used to demonstrate the experiment's accuracy. The slight difference between experimental and theoretical value could be due to the measurement uncertainties or the influence of minor effects that were not considered. As the percentage error formula, theoretical value will minus with experimental value divided by theoretical value times by 100. The graph does not have a constant increment when the speed increases from 0 to 255 due to the oscillating dynamic of the spring mass system corresponds to a real physical system in which the amplitude of the oscillation gradually decrease and disperse after a given time interval. The value obtained for car 1 or x1 and car 2 or known as x2 was slightly different. This is due to the influence of the spring, such as the compression effects on the coil of a spring, as the position of the spring and the car body is different from each car. For recommendations, the material used can be improved by changing into a more suitable material such as steel because it has a higher durability. We can also use a better spring for a better spring compression. Next, dimension in this project might be improved to match the actual dimensions and smoother surface contact area between the tire and the track. Moreover, we can also program a software that can display the results on the LCD for an easier observation of the data. In conclusion, the objective of the experiment conducted have been achieved. The geometric parameters of the spring have a significant influence on the simple harmonic motion of a spring mass system. When a 2 degree of freedom system is subjected to a harmonic force, it will vibrate. The smaller the natural frequency, the more force is exerted. The project's components are printed using polyethylene terephthalate glycol, or known as PETG, as a material in 3D printer. Lastly, the experimental and theoretical results are compared to prove that the experiment followed the basic concept of the theoretical. That's all from us, from Group 1.